Hi everyone, in this video we will see a direction, speed and angle control of stepper motor using ARM processor. So first what we need to do is we need to initialize the header file. So you can include a header file, LPC2148 header file. Next we need to give a delay, a void delay in terms of millisecond. Next I am going to declare a void step clockwise. So in this program we are going to rotate the motor into clockwise direction. Suppose if you want to rotate the motor into counterclockwise direction, so here you can change void step CCW. So this is a loop for rotating the motor into clockwise direction. So in this loop what we have done is we have to first initialize a general purpose input output pin as a output pin. So here the IO pin I'm going to use for loading the sequence of data. As you all know that the stepper motor stator coils we need to sequentially energize, then only the rotor can rotate either clockwise or a counterclockwise direction. So in this you can see the data which I've used for rotating the motor in clockwise direction is 9, 5, 6, A. If you want to reverse the sequence A, 6, 5, 9, the motor can rotate into counterclockwise direction. So first what we need to understand in this particular loop is, so the port pin what we have used here for the data where we want to send it through the output port. So here port 0 to 3 I am not used, so I have just declared as 0, 0, 0. Then the port 4 to 7 is used for storing the sequence of data. That's what it is given as 90, 50, 60, A0. But basically what we are doing is we are giving the data 956A for energizing the motor into clockwise direction, because the port 4 to 7 is connected. That's what it is given as 90, 50, 60 and A0. So first if you send the data 90, the motor will take single step, right? So after that we need to give a delay, then we need to energize the next set of winding. So next set of winding in the sense we need to give a data for energizing the next pair of winding. So here the data 5 is given, 50 is given for energizing the second set of winding. After that we have to give a delay, then you can give the third data, then delay, and fourth data, and you can give a delay. So whenever we execute this particular loop, the motor can take 4 steps. So here the stepper motor we are going to rotate up to 90 degree. For this you can use a for loop. In this for loop I is equal to 0, that is initially we are going to make this variable as 0, then I is less than 13, I plus plus. If you look at the step angle of the stepper motor, the step angle of this motor is 1.8 degree. For each step the motor can rotate 1.8. If you want to rotate the motor into 90 degree, we need at least 50 steps, right? So 90 divided by 1.8 will give 50 steps. So if you use the step clockwise loop, the step clockwise loop we have 4 data 9, 5, 6, A. When we give 9 data, the motor will take single step. When you give 5 as a data, it will give another single step. So like that, whenever the 4 data are executed, it will take 4 steps, right? So that is a step clockwise loop. So here what we are doing is we are going to call this loop, it is going to be executed 13 times, right? So 13 into 4 will give 52 steps, but actually what we need here is 50 steps, and only the motor can rotate up to 90 degree. So this is, you can say that the stepper motors are generally used for a precise control or precise positioning system, right? So here if you declare this I is equal to 12, for example, if you take I is equal to 12, so 12 into 4 you will get 48, right? So the motor can take either 48 steps. If you give I is equal to 13, the motor can take either 52 steps, right? So either it can get 48 or 52 steps, but we need accurately 50 steps, then only it can say that the motor can stop exactly at 90 degree. So we can say this is the reason we can say the motor is generally used for a precise positioning or a precise control. So the motor can take either 89 degree or it can reach to 91 degree. So if you give 13 as a value, the motor can take 91 degree. If you give I is equal to 12, the motor can stop at 89 degree also. Okay, so this is a step clockwise. After that you can close the loop. Now you can declare the void main. In this void main you are going to use a GPIO pin. Direction is declared as a output pin. So here the port what we are using for sending the data is, we are using only port 0.4 to port 0.7 as the output port. So here you can make all the port pins are 111, that's what it is given as F0, right? So through this port only we are going to transfer or send the data, the sequence of data 9568. This data will be sent through this port P0.4 to P0.7. For this, we need to make this port as 111, that is F value, right? Then you can rotate 90 degree, then you can close the loop. Now you can see the last loop is a void delay loop. In this delay program, we are going to declare two variables I and j. So this is a loop inside the loop. So we can say I is equal to 0. Then you can give some hexadecimal data and you can give incremental point. Then you can use a for loop. J you can define as 0 and you can give some kind of a hexadata decimal data and you can give the j++ and close the loop. So if you see the first we need to define the motor to be rotated in clockwise or counterclockwise direction. For this, we need to create a loop and give the sequence. So here the loop is used for stopping the motor at a particular angle. Okay, either 90 degree, 180 degree, like that we can define. This is the third loop, is used to configure the port where you want to send the data. Okay, so here the port is 0.4 to 0.7 is used as an output port. And the last loop is nothing but the delay loop. So if you want to change the speed of the motor rotation, we can change the delay value, right? If you want to change the angle, 180 degree or 360 degree, if you want to stop the motor, you can change the I value, right? So if you want to change the direction of the motor rotation, so you can go for a step clockwise loop and you can change the sequence of data. Okay, thank you.